Can you fix the thumbnail? Because as of right now, it's just our team's profile picture. Actually, I can probably fix that. Hold on. It's not one. Okay. And I'll be in the chat so that we can have chat coverage if you need. And it's probably gonna take a couple seconds to refresh. I think that's fine. I'm gonna get started basically right at 11:30, so just
Alright,
to
sounds good
let
to
you
me.
guys know. Okay. Oh my god. Yeah, you definitely shouldn't go into work with that. Doesn't seem healthy. Yeah, we gained a subscriber in the past, like, 10 minutes. Also, they can definitely hear us on stream, by the way. Okay. Good to know, good to know.
Alright, it's time to get started.
Yeah, alright. Welcome everybody to our second week of RoboU. This week we're going to be tackling game analysis and strategy. So we'll give everyone a couple minutes to jump in if they're going to, and then we'll get right started. Just gonna make sure that we have everybody here that needs to be here. Just a couple minutes. All right, so we're gonna start with some general background information. So if you can go ahead and just put everything up on the slide. If you aren't aware, we are a first robotics competition team. We have a general timeline to our season. So the game is released every year in January. There's a new game every year except for the anomaly that is 2020 and 2021. Build season lasts for around 6 weeks. Competitions start in early March. We have two guaranteed competitions, being our district events that we pay for at the beginning of the season, and the World Championship is in late April for us. So I'm going to use this to lead into Jacob Carroll's segment, and he's going to tell us about game analysis.
Hi guys, I'm Jacob Carroll. I'm the previous COO of the team, and I was on the team from 2015 to 2019. So I'm going to be talking about a little bit about game analysis. So to start off with, we have the kickoff every season, and this is at the beginning of January. And kind of what our team does to best prepare for the season is we all have a big meeting on the very first day of the season and watch the reveal together and get all of the game manual and rules and restrictions and just read through everything. So the first thing that we do is we split into small groups, and each group is assigned a section to read, and then they come back to the larger group and present what they learned from their section, kind of like so some groups might be like robot design. So what are the weight requirements, the height requirements, perimeter, all those kind of things. And they'll kind of make a short presentation to inform the rest of the team so that we can most efficiently get through all the crucial information in the manual. Because there's a lot of very important information, and there's kind of a lot of information that's in there that not everyone needs to know. So like not everyone needs to know like pneumatics guidelines, but it's important that someone on the team does. So that's the very first step of any season. So the next one is how do we play a game? So the most important part of the game manual is the gameplay part. So that's where you find out what is the goal of the game. So are we trying to score balls into hoops or throw a cube into a basket or something like that? And so for this section, we break it down again. So we separate into these same small groups, and everyone reads the gameplay section. And this is to cover like how the best way to score points is, and where can we start in autonomous, those kind of simple things. And what they do then is they develop a strategy to say, all right, here's how the game is played. What does our robot need to accomplish to do the best job to win a match? And so that's all they do in that second breakdown, is they do that quick little analysis and say, all right, we need to do X, Y, and Z, and it's most important that we do X. Y and Z are kind of like, if we have time, they're nice. And it's very important that this part is not about building a robot. We're not trying to design a whole robot in 10 minutes, because there's a million different aspects that we'd have to consider. And the main thing is that we're focusing on is just how we want our robot to function. So once every small group does this, we head back to the larger group, and each group then presents their ideas. And it's important to do this because we're getting a bunch of different ideas all from the same book or from the same manual. And what this allows us to do is to see the game from a bunch of different perspectives, because every single one of those ideas that a group presents, we're going to see at some point in the season. And we will know how that design's weakness and how to like beat them in future matches. So we want to see, all right, so Group A's design, it doesn't really have an end game, so we're losing out on a lot of points there. And so what we do then is we talk about the pros and cons of every group's designs or ideas for the strategy, and figure out which one the best fit is for our team. So with our resources and our time and our student base, we're like, all right, we can probably achieve Group 2's design the best, or strategy the best. So the next step is to take that strategy and move into strategic design. Can you go to the next slide? All right, so the first part of strategic design. So this is moving into the second day into the first week of build season. What we usually focus on, first of all, is prototyping. It's very important to prototype. It's very difficult to know how game elements are going to interact with shooters and climbers and intakes without seeing it practically. There's a lot of documentation on stuff like Chief Delphi about how to efficiently prototype and how to know what kind of intakes and shooters and climbers are the best. So like historically, for example, intakes, you're always going to want to look for wheeled intakes. That's just one of those things that over the hundreds and hundreds and hundreds of prototypes made throughout the seasons of first, wheeled intakes have just been superior, hands down. And this is with any game object ever. So those kind of things we can kind of first, like going into prototyping and saying, hey, we are just going to focus on wheeled intakes, and we're going to have one group go ahead and prototype and design one of those. So with this, we are looking at a bunch of different aspects, is how can we do well at district events? So we're trying to build a robot that can do well at district events, because if we don't do well at those, we can't move on to further events. But we still want to build a robot that has that potential to do well at, say, World or District Champs. So that all comes together in the strategic design portion on how to make the fastest shooter or the fastest climber, because in all of these aspects, like, time is so important, just because we have such a limited build season. And so, like, one of the final steps of strategic design is coming to conclusions about prototypes. So usually after week one, we try settling on designs at that point to begin to build because um, historically our team has needed about 3 to 4 weeks to build final products of any of our designs. So it's important that we get a early start on what we want, and so we can send that off to say the mechanical team to start building some final versions. And even those final versions usually need to be tweaked in one way or another, just because with prototypes using wood or PVC is going to interact with the game elements slightly differently than say like metal or um, some Lexan or whatever we choose to use. And so that's kind of the early build season, first 1 to 2 weeks, where we're trying to just design and focus on the strategic aspect of the game. So some other parts to strategy and design is going into the matches. So Dakota is going to take over for pit scouting and kind of talk a little bit about that.
Yeah, so pit scouting, you can go ahead and go to the next slide. It happens basically on the first day of your events. You'll take a group of about 3 or 4 students and you'll split them up to go talk to a bunch of the teams at the event. Basically, the whole goal to this pit scouting is to gain information about what people's robots are like. How they're not necessarily how they're constructed, but how they work, and how they'll be able to score and stuff. So you'll ask questions like, how can they score? What do they do in autonomous? What are their mechanisms? Like, uh, what's going to be the thing you can rely on for them? So you ask them, what kind of intake do you have? And they say, oh, we have a claw that picks up the balls, and you write that down so that you know that for later matches. And then you write down, you ask them about their drivetrain. You ask, if they say they have a Mecanum drivetrain, you know that you probably shouldn't be putting them on defense. Or you ask them also their driver's experience. So they say our driver has been driving for a year. He did really well last season. You write that down, and you keep that in mind when you're doing match strategy. So in the first few qualification matches, you won't have any actual scouting data from the matches you've played, because there won't really be any matches they've played unless they got like one of the first matches. So this is used to help with the first few qualification match strategies, and then it also usually will take a couple more inexperienced students, and that'll help them get more familiar with robots and more familiar with how everything works, and that'll just help them overall. And then if we can go to the next slide, we're going to be talking about match scouting, which is the second part of scouting at events. So match scouting, basically, you're in the stands with 5 other people, and you each pick a team on the field, and you're watching matches, and you watch your one team play. So you will write down what they score in autonomous, where they start on the field, and whether or not they climb or do whatever the end game task is. And you'd also write down notes about like, oh, they got disabled mid match and then they didn't play the rest of the match, or they played defense and they got a bunch of fouls, or they played good defense, they kept the other team from scoring and got minimal fouls. So this data is collected and it's used for your future match strategy with these teams, and it's also used for alliance selection. You look at this data and you say, oh, this team is a really good team. They've scored a lot of points over these matches. They're consistent. They can do what they say they can do, and that's why we should pick them for our eliminations alliance. And then good scouting data, no matter where you rank, it will make you valuable. So if you got a decent robot and you get picked by, let's say, the seventh seed alliance, they're gonna look at you, and you're gonna say you have scouting data, and they're gonna be like, okay, who do we pick? We don't have, if they don't have as much data, they're gonna be like, who do we pick? We need to be able to have a solid third robot so that we can play well in eliminations. And what I wrote here is data helps make good picks, and picks help make a good alliance. So having good scouting data will never, I don't think, will ever hurt you in a competition. And if we can go to the next slide, I'm going to hand it over to Jacob once again to talk about match strategy.
All right, so for match strategy, this is probably like the most important part of scouting. So a lot of what's overlooked in scouting is a lot of teams just use it for alliance selection because they're saying, all right, so we're just trying to find the best teams, and our scouting will tell us where the best teams are if we're picking. And so what we do is a completely different take on that. We use scouting in every single time we touch the field. If that's alliance selection, if that's just the very first match of the competition. So we're going to look at everything that the students gather from pit scouting on how much a robot weighs, what kind of drivetrain they're using, and we're going to use that to help us develop a strategy. So as we pointed out here, so there's a lot of things that we're looking for when going into a match. And I'll kind of talk about how each one of them is based on something we do with scouting. So the first thing that happens in every match is autonomous. So it's important that we know other teams' autonomous routines. So in scouting, very often we'll track the team's progress from where in the past they've done in autonomous and see where we can complement that, and if we can run our most optimized routine in combination with these other two robots. A lot of times at lower level competitions, say like a district event, there's only going to be one other team on our alliance with a reasonable autonomous. But as we get to higher level competitions, say like world championships, there's going to be teams, even at the very lowest seeds, that can do very complicated autonomous programs. So some other things is teleop and defense. And so this is the main game portion. So what do we want to accomplish during the match? So we're going to always have our go-to game plan, and we're going to try talking to our partners about how to complement their go-to game plans with ours. And so that's going to be a lot of based on what we've seen them do in the past, and say, all right, we've seen you can do task 1 and 2 very well, but you struggle in task 3. Why don't we do task 3? Since we do task 2 and 3 well, you already have task 2 covered. All right, we're just going to focus on 3, and then we're going to have all the different aspects of the game covered, because that's one of the main goals. Is we don't want to be in our own team's way. That's one of the things that really led us to success in 2019 was our whole strategy was we're never going to get in our own partner's way. And we saw that a lot on teams that just bogged them down, was they could not get out of each other's way, and they were playing defense on themselves, essentially. So that's one of the main important things we need to talk about before a match happens. And then every competition, there's an end game of some sort, whether that's get on some kind of platform, or to do a climb of some sort, or to be in some kind of zone. So we don't want to, again, get in each other's way for end game. So it's important that we communicate and say, hey, there is only one climb platform, and we have hit our climb 100%, and we see from our data that you've missed it 50% of the time. So I think that we should take it. Or if it's the other way around, we always want to make it important to optimize the points. We're not always trying to just show off and get our team to do whatever we want. We want to do what's best for the alliance all the time. And if that means that we're doing something that we're not comfortable with, that means that we need to be the more flexible teammates here. And then after every match, it's very important that we say, hey, what went well, what went poorly, and what can we do to improve in the future? It's a little, like usually the drive team will get together and have a couple notes. And obviously the drive team has a certain perspective on the game, but the people in the stands have a completely different perspective. So it's always important to get their feedback to help figure out what went well and what went poorly. All right, so the next section is alliance selection. So this is kind of at the end of a competition, usually the last day. Um, this is where a majority of the points are scored for district events. So it's very important that we're on our game during alliance selection and eliminations. So we always are going to use our data to pick the best partners. This is why every single match it's important that we have the most accurate data we can. And because if we go into our alliance selection and pick a team based on some false data, then we're hurting ourselves in an area that we could have avoided. So there's always going to be a certain type of robot that we're going to be looking for. And so it's very important that we find the best of that type to complement our robot. So usually we have, if we're picking, so we're going to have a high ranking robot. That means that we focused on ranking points in qualification matches. That means we're going to need a point scorer for our first pick, because usually that means we're focusing on tasks that have a slightly less point value since we're going for ranking points. So we're looking for someone who can score the most net points, but isn't interfering with our game plan so that we're also scoring most net points. And so there's a lot of strategy that goes on here because especially at district level, when there's a lot of teams who have a lot of history together, like us and the Stags, we have a lot of history of playing together. We are very successful with them. And what a lot of teams are going to try doing is separating us. And we need to be doing the same thing to them. It's hey, we can't have Sparky and Bionic Eagles together. They're just too good of a combo. So how do we break them up? Do we need to pick one of them, even though it's not the best pick for us, just to stop that combination? Because the whole point here is, yes, we want to pick the best team for us, but we want to pick the best team to help us win. There's a big differentiation there, because if we're picking the best team for us, but we're giving a better team to someone else, it's always better for us to pick that better team and take the slight loss there to completely eliminate a broken alliance. So that's always something that we need to be looking for, and it's very, very fun to do that analysis at the end of a competition with all that data and all that those different outcomes in your head. So then you have elimination rounds, which are a completely different ballgame than the qualifications, because ranking no longer matters. It's all about who can get the most points on the board at the end of the match. And so usually this means we're adjusting our strategy a little bit. We're not going for maybe a ranking point objective, which we were going for in qualifications. So for 1 year, like in 2019, like filling a rocket, we're not focused on that anymore. It doesn't matter. Of course, we didn't focus on it ever, but a lot of teams did, and we need to adjust how we're going to play defense on those teams who did, and maybe where their weak areas are, because a lot of these teams aren't used to fighting for maybe different kinds of points. So we can take advantage of those differently played aspects of the game in eliminations. And what I see a lot in eliminations is it's like a very elaborate game of rock, paper, scissors, shoot, because you're always going to need to play the strategy that beats your opponent. And so one thing that we've always done well is we're a very flexible team strategically. So we can be a rock or a paper or a scissors. And so the most important thing is figuring out what our opponent is before the match starts. So if they're a rock and they do one thing every single time, it's really simple for us to say, for our scouting team to say, hey, if you guys just play like paper, you're going to beat them 9 times out of 10. And so we're like, perfect. And so that locks in our strategy to help us win the game. And so it's a lot of adapting and changing to figure out how we need to play the game to beat our opponents. And ranking is always important going into alliance selection. The second that all the teams are placed, ranking doesn't matter at all. because historically we have never looked at ranking when picking teams, but it's important that we have a high ranking if we want to control our destiny here, because that means that maybe we get to become a captain or we have the power to decline a pick. So that's very important. Is say we're in the ninth seed, it's very risky for us to decline a pick because that opens up the possibility of us not being able to play in eliminations at all, which would be a terrible way to end any match. But then, on the other hand, it could be a high reward because say we do get moved up if there's some inner picking and we get to play as a captain, maybe from the 7th or 8th seed, then we get to choose our next two partners. And whenever we choose partners, we do significantly better just because we have such an amazing scouting team. And they always give us amazing picks to work with on the field. So it's very important that we rank well and know how to control our destiny, because we have done extraordinarily well whenever we can get a high seed, say like a 1 or a 2 seed, and have some of those top tier robots on our team. All right, I think that kind of covers it for match strategy and alliance selection. I think that's all that we're going to cover in this presentation. Is there any questions from anyone in the chat? Or Dakota, did I miss anything?
I don't think you missed anything. You went over pretty much everything. We're just gonna wait for questions in the chat here, and if we don't get any within the next few minutes, we're gonna wrap it up. Except we have to present the safety presentation as well, but that's more of just a recap for people that didn't show up last week.
All right, doesn't seem like we have any questions.
Yeah, it doesn't look like we have any questions. If any questions come in a little bit late, I'll be happy to answer them. But for now, I think we should say thank you to Jacob Carroll for his time. He, took time out of his day to come help us with this presentation.
Thank you, Jacob.
And then we're just gonna present the safety presentation again, so that people who missed it get to actually see it. But yeah, I think that's for strategy and game analysis. That's it.
All right, thank you guys for coming. I'm gonna go ahead and play the safety video.
All right, thank you guys so much. See you later.
Bye-bye. Forgot to unmute it.
And here with us is Jacob Butler, who's going to be taking us through the presentation.
Yeah, hi, some of y'all know me, some of y'all might not. I'm an alumni on the team, and I did safety on my time on the team, so I'm going to be helping out with the safety PowerPoint today. So right now, we're just going to go over some of our general PPE guidelines and how that is going to affect us with COVID-19 going on. So it's important to note here that we don't have a full set of guidelines from the county yet. We're still working on all of that. So this is just our general setup and what we'll be doing. And you can go ahead and just put everything up on the slides then. So we have PPE that's required at all times, and this is again just for general shop, and then we're throwing in all the COVID-19 guidelines that we're setting up right now in there. So safety glasses at all times in the shop. Those have to be clear and see-through. You can't have any tinting in them at all. We have to be able to see your eyes. Closed-toe shoes are required at all times in case you're dropping anything. They don't have to be steel-toe. I would suggest something steel-toe just in case you roll something over your foot, you drop something on it, but closed-toed at least required at all times. Hearing protection is required on your person at all times and used when you're running loud equipment. Again, I would suggest using it when you run any type of equipment. you'll hear constantly people complain as life goes on, they lose their hearing and they'll blame it on being in the shop, being around loud machinery. So wear your hearing protection. And then obviously a mask will be required at all times in the shop. At no time will you be able to take off your mask. If you are in your car alone, that's probably the only time you can take your mask off. But if you are in the shop with other students, you have to have your mask on. When you're within 6 feet of another person, you need a face shield. So we're going to be getting close and working on the robot. We're going to be within 6 feet. So you're going to have a face mask for that. No jewelry of any kind is allowed. No rings, necklaces, earrings, any of that is allowed. Rings can get stuck in machinery and pull your fingers off. Your necklaces can get stuck in something spinning and pull off. No lanyards around your neck or anything like that. Long hair has to be tied back, preferably in a bun, not a ponytail. A ponytail can get caught in something. Baggy clothes you got to keep rolled up, so like your baggy sleeves, make sure you roll them up when you're using machinery because they can get caught in something.
Hey Jacob, can we pause for just a second? We're having a little bit of technical difficulty because there's music that's showing up that we're not sure about. Yeah, you can go ahead.
Can we still hear the music or no?
It's all good. Everything's good.
Awesome. Gotta love it. Okay, so yeah, hoodie drawstrings need to be tied up or tucked in because those can get caught in machinery and get yanked out too. And then that is our general PPE requirements. So next we're going to be going over how we're going to be handling injuries in the shop. So any injury to any team member must be recorded via an injury report form. These are in our binders. Your safety captain knows where that is. Mentors should know where that is too. You need to make a mentor aware of any and all injuries, no matter how minor. So even if it's a small cut can turn into something worse if it's not corrected. So all the recorded injuries will be used to improve the safety culture of the team. So we're going to use them to make changes and improve. And then our goal should be to have 0 injuries. Obviously, that's ideal, but that's what we're going to try and do. And again, before we move on, I think it's important to note, again, we don't have our full COVID-19 guidelines, but in addition to anything we show you and teach you today, there's going to be precautions made in place for that. So things are going to be kept clean. People are going to be following the social distancing guidelines. We're going to be doing whatever the county tells us to do. But today is just a general safety, what you need to know for a regular season to keep yourself safe around tools and machinery. Okay, so now we're just going to go over some general shop safety. We're not going to go into anything super, super in-depth in the general, but just some stuff to keep you safe that you need to know about. So it's important to note safety is everybody's job. So it's not just it's not just the safety captain's job. It's not just the mentor's job. Everybody has to be aware of safety. Safety isn't a priority. Priorities can change. Safety is a condition of being in the shop. It's something that goes on always. So everyone needs to consider themselves and others whenever you do anything in the shop. When you're running a piece of machinery, when someone's running on a piece of machinery, when someone's working on something, you need to be aware of what's going on and respect other people that are in your area. Make sure that everybody's following the rules. We're not asking you to be a dictator and start going around and checking everybody and making sure they're doing what's right. But if you see someone start a machine and they don't have any safety glasses on, or if you see somebody about to lift something or move something unsafe, make sure you say something. And you can do that respectfully. You don't have to be disrespectful, but it's just important to make sure that everyone's looking out for each other and we're creating a safe environment for everybody. So just a little bit about shop equipment here. So if you haven't used a piece of equipment before, you need a refresher, you got to be accompanied and taught by a mentor. So if you go, hey, I don't know how to use a bandsaw, I've never used a bandsaw, get a mentor and they'll teach you how to do that. So again, one thing that we plan to do, we're going over safety today, but what's super important is actually being in front of the machine and seeing it used and then using it yourself so you understand how to operate the equipment safely. And that's something once we have all the guidelines and once we figure out what's going on this season with in person, we will get that done. That's going to happen. But if you don't know, or if you say, hey, I know we've been taught on this, but I don't really feel comfortable, can I have help? 100% mentors are there for that. No one expects you to know how to use every piece of machinery. No one expects you to know how to use it for life. But if you need help with it, there's going to be someone there who can help you. So every machine has its own set of rules for safety and housekeeping. Things need to be cleaned off before and after use. Everything needs to be, done in a safe manner, and not every machine is run the same way. So you need to make sure you know what the safety guidelines are for each machine. Make sure your work area is clean before and after using the machine, or before and after working on anything. You don't want to set down a part on the top of a dirty area and start working on it. You don't want to run a machine that has a bunch of scraps in the way or anything. You want to make sure your work area is safe. Yeah, when you're cutting material like on a drill press or a bandsaw, excess waste that comes off of that is often really sharp. So metal shavings, sometimes even pieces of wood can splinter. You need to make sure that you're not grabbing that, that's not getting flung anywhere. Make sure that it's getting cleaned off with a brush. You don't ever want to use air to spray anything off. That's dangerous. It can put dust up in the air. All right, and we're moving on to hand tools. So it's important that you are using the right tool for the right job. A screwdriver is not a hammer. A wrench is not a hammer. Do not use it like a hammer. That's improper use and can cause damage to the tool and could possibly cause a tool to break and hurt somebody. You also don't want to use broken or damaged tools. So if you see a tool and you go, hey, this piece is kind of loose, this doesn't look right, the end of this is mushroomed, it's straight up broken here, do not use it. Tell a mentor when you see a tool in bad condition, or if you're unsure of its condition. If you go, hey, I don't know if should be like this. Is this right? Ask a mentor and they'll help you out. Be aware of where your hands are when you're working. I know that sounds kind of silly, but if you're holding something in one hand and using a screwdriver in the other hand to screw something into that piece, make sure that you're not applying so much pressure that you slip and stab your hand with the screwdriver, things like that. When you're drilling, make sure your hand is in the right spot. When you're putting a screw through something, make sure there's like no hand or piece of material on the other side. Make sure you put tools back where you find them. That's a big issue in the shop, is keeping things orderly. Make sure the screwdriver is going in the bin marked screwdriver. If we need a screwdriver for something, or we need a tool to pull something apart, we want to make sure we have access to it and know where it is. So, and don't leave the tools out unless you intend to use them. Obviously, if you're working on something for a period of time, you can keep the set of Allen wrenches out, next to you. But if you're done with that, try and put it back. Keeping stuff out isn't really smart. It gets in the way. We lose things. Just make sure you put things back where you find them, and treat the shop and the tools in the shop better than you would treat your own. It's important that we leave the shop better than when we found it. It's important to leave the tools in a better condition than when we found them. All right, battery safety. This is really important because obviously all of our robots are going to be using a battery. They're really more dangerous than you think, and it's important to keep them safe. When you're moving and carrying the batteries, always use two hands, never hold them with one hand. They weigh a lot, and you want to make sure you get a good grip on them. I normally put one hand on the side, one hand underneath, put both hands on both sides, whatever works best for you, but never hold them by the wires. You're just going to rip connections off, and that's a problem. Never fun for anybody. The batteries normally have a protector that goes in the in connector. It's just a plastic piece that sticks in so that nothing can get into the connector. If there is a battery that isn't connected, it needs to have one of those connectors in it. The only time that there's even a slight exception for that is a battery that's in the robot and has been disconnected for some purpose. If there are batteries on the side somewhere, if there are batteries and a charger that aren't plugged in, they need to have those connectors in there. If a battery is broken for any reason, you need to let a mentor or safety captain know. The safety captain will notify a mentor. It's not anybody's job specifically to clean up that battery spill. We want to leave that to a mentor. The safety captain will be trained on how to do that. And we have a battery spill kit located in the tool cabinet. So it's just an acid, and you want to neutralize the acid and then sweep that up. You need to use the right kind of gloves. It's something it's like putting out a fire. Not everyone is expected to use the fire extinguisher, to use the battery spill kit, but you need to know where it is, and there needs to be a person designated who's going to use it. All right, and next, moving and lifting. So this might seem kind of silly, but it's really important that when you are taking something from one side of the shop to the other, or you're moving anything around, that you're doing it in a safe manner. So you really want to plan your path from A to B. It's like, okay, we're moving these boards from, the garage doors in the shop to the area where we're working. We need to make sure that, there's not stools and stuff in our way. No one's going to trip on the way. There's not cords and like material laying on the floor that we're going to trip over. Make sure that when you are moving a large object, you are aware of where people are and where that object is, the geometry of that object. So I'm sure you've seen cartoons before where someone's holding something over their shoulder and they turn and whip around and knock somebody over the head or knock somebody over. We don't want anyone doing that. Make sure that you're aware of what you're holding, where you're moving it. When you're lifting heavy objects like the robot, you want to make sure you're lifting it with 2 hands and you're lifting them with your legs and not your back. I know that sounds like something you'd say to an old person, but you really want to make sure you're lifting with your legs and not your back. You can cause serious injury that way, and it's just how you should train your body to lift these things. It's the best way to do it. Okay, now we're moving on to machine safety. So this is for the specific machines in the shop. And I want to say again, this is not a substitute for actually sitting in front of the machine and running it and being taught how to run it in person. Again, we're going to try and do that as best we can with the guidelines. And if we have people working in the shop, we're going to be training them how to use the machinery safely. So just take that into consideration when you're looking at all this. These are just general safety guidelines for the machines that we use, but there is, more to using the machine. So this will teach you how to use the machine safely in a safe manner, but again, it is not, in place for actually running the machine in person. So first up is the drill press. When you're running the drill press, you want to make sure that the material that you're trying to cut is clamped to the table. There's also a little vise on one of our drill presses in the shop, so whatever you need to drill through needs to be clamped to that. Most of the time, when you're trying to hold a piece there and you drill into it, it's gonna spin. You need it clamped down because the drill bit is gonna bite into it and immediately try and spin the work instead of cut through it. So we generally use scrap wood underneath the piece that you're cutting so that you don't cut through the table. The drill press is designed to the table have a hole in it and the drill press goes through that, but sometimes the table is moved or it's not set up accurately or there's other stuff in the way like the vise that's there, and you want to make sure that you are not drilling through the table or drilling through any equipment that's used to clamp your piece of material to the table. Make sure you remove any scraps that are on there with a brush and not by hand. So for example, if you're cutting through a piece of aluminum, normally there'll be aluminum scraps. You want to brush that away and clean the surface instead of scraping over it with your hand so that those flakes don't get stuck into your hand. It's the same thing with wood. It'll probably be small, like uh, pieces of wood, but they won't really splinter, but every once in a while you'll get splintery wood in there, and you really don't want to clear that with your hand. You want to make sure you're cutting at the right speed. So for some material, you want to cut at a different speed. Uh, that that's more specific to again the bit you're using and the material you're cutting through. And you want to make sure you're doing that so that you're not, cutting super slow through a piece of material. It could be dangerous. And you never want to slam the press down. You don't need to go inchingly slow, but you don't want to slam the press into the material and go at hyper speed when you're drilling through it. And you want to make sure you wait for this machine to stop spinning before you reach and try and clear out any material. Also, I believe one of the drill presses in the shop actually has a slow release to it. So when you release the handle, it goes up slowly, sort of like closing a door. It's critically damped so that it's not just going to fly all the way back up, but not all of them are like that. So we make sure when you're releasing that handle that it goes up slowly and doesn't slam into place. You want to also make sure that before you use a bit in the machine that bit isn't broken or damaged. That could cause the bit to crack when you're cutting through material and launch shards everywhere. And you also want to make sure any guards that we have are in place when you're using the machine. Bandsaw is a piece of machinery in our shop that gets a lot of use out of it. So it's really important that you're operating this machine safely, and respect it and respect people who are using the machine. So the blade guard is the piece that covers the blade and it sort of holds the blade in place and keeps it from wobbling. So the bandsaw is a continuous loop of cutting blade that's in that machine. And you if it's not held in place properly, it will flex and bend. So you want to make sure that you're using the least amount of bend and flex as possible to be making sure that you're not going to flex that blade in a way that it's going to break. So the height of that blade guard needs to be a quarter of an inch above the material that you're cutting, and it needs to be locked in place. Normally there is a like turnkey on one of the sides of the bandsaw, and that needs to be locked in place so that it doesn't move up or down. You want to keep your hands as far from the cut as possible, and you never want to cut small material. And what I mean by small material, I don't mean thin material. I mean a piece that is very small. So if you have like a square piece of wood that is an inch by an inch, you really don't want to be cutting that or anything smaller than that on the bandsaw. That's super dangerous. Your hands are really close to the cut. It could pull you in, and that's just not ideal. You want to use the proper guards when necessary. So sometimes you can attach a guard on the side that will keep your piece straight, and you can just push it through, and that reduces the amount of hands that you have to have in the scenario. So you want to make sure that you're using those when necessary. When you're cutting something circular or rounded, so for example, if you have like a parabolic curve that you have marked on a piece of wood and you want to cut that out, make sure you make relief cuts. And relief cuts are straight cuts that go into the edge of the curve, and then you're cutting out essentially tiny pieces of material instead of one long curve. So they're sort of lines that would normally be not tangent to the curve, but straight against the curve of like the side of a semicircle. And then you're cutting through all of those instead of just one line of the semicircle. If you ever need to stop cutting, so let's say you're cutting a straight line into a piece and you decide, oh, I need to stop and then cut through the other side. Make sure the material stays where it is in the cut. You turn the machine off, keeping the material in the same place, wait till the blade stops, and then you can back it off from the blade. Never back a piece of material off of the blade while it's running. It's super dangerous. You risk breaking the blade, you risk messing up your material. It's just not a good thing to do. You also don't want to use excessive force. Don't slam stuff into the saw blade. That's dangerous. You don't need to be, again, pushing anything through at hyperspeed. It's going to cut. Don't be super slow either as to just sit there and burn material like wood. But again, you don't need to be flying through stuff. Just go with the cutting speed. You'll be able to feel it when you use the machine. And again, remove any scraps with a brush and not by hand. All right, next is the table saw. So the table saw is a really useful piece of machinery that, again, gets a lot of use, especially when we're making field elements. So you want to make sure that all guards are in place before you start the machine. Our table saws have a guard, it's like a clear plastic guard that goes over the top of the saw blade so that the saw blade is never out in the open while it's cutting. That is really important to have in place. It'll slide out of the way when you move stuff through it. It needs to be on there. You want to make sure your blade height is roughly 1/8 of an inch above your material, or about like one sawtooth height above your material. So what you'll do, let's say you're cutting a piece of wood, you'll slide your piece of wood up against the saw, you'll turn the knob on the table saw until you see the blade rise about 1/8 of an inch or 1 tooth of height above that material, and then you'll keep it there in that place. And you can lift the guard up for this reason, and then you have to lower the guard back down when you do that. You want to make sure you keep your material absolutely as flat as you can against the table to avoid kickback. So what kickback is, when you're pushing a piece of wood into the saw or a piece of material into the saw, and it's not level on the table, the saw is spinning so fast and has so much grip that it is just going to grab that piece and launch it right back at you. If you're cutting through and the saw is actually making it all the way through the material, you're keeping it flat and you're pushing it straight, that shouldn't happen. You should never get kickback. But if your material is riding up onto the saw, it's almost always going to kick back. You want to make sure you're using the right guards for the right job. So there's guards in place for ripping and cross-cutting. So you need to make sure you're using the right one. In this picture here, in the bottom right, it's kind of on the text a little bit, but you can see that there's a guard on the side there. That guard locks in place and allows you to make a straight cut. And again, that's keeping you from holding your hand in that one spot. You also want to make sure, again, the material is flat against the guard and is in place. So the guard is useless if you're not actually pressing the piece of material up against that guard. Also, push sticks are one thing that we use to keep your hand away from the blade. It's essentially just like a wooden or a plastic stick that pushes down on the board, and you can use it to push through the blade. So it keeps your hand away. If you have a lot of material in between the guard and the blade, you can use your hand. But when you have less than probably 6 inches of material, I'd suggest using a push stick. And the table saw is arguably one of the most dangerous machines in the shop. It can cause kickback. The blade is spinning very fast. It's exposed. You want to make sure you are treating it with the respect it deserves. You need to make sure all the guards are in place. You need to make sure that you have people, standing away from the machinery when you're using it. You need to make sure your hands are moving in the right spot. Your material is flat. Just treat the machine with respect. You don't need to be afraid of it, but just know that it is a dangerous machine. So in our shop, we have 2 chop saws. We have one that we use in the wood shop for wood, and then we have one in the main shop that we cut metal and material like that on. So they're both fairly loud, but the metal one specifically is extremely loud. So when you're running the metal chop saw, ear protection is required for you, and let people in the area know that you're running it. It's very loud. It's jarring when you hear it go off. So make sure that you're saying, hey, I'm going to go run this. I'm going to go cut a piece of material on this. Use ear protection, and just be courteous to people around you. It's also important to note here, just as a general requirement when using any of the machines in the shop, make sure that when you're using the machine, that's what you're focused on. If you see someone using a machine, don't call their name, don't scream at them, don't horseplay. It's very serious. Someone can turn away, and then the next thing you know, they're cutting something they're not meant to be cutting. So any material that you cut in the chop saws, you need to make sure it's clamped down and it's tight. You need to make sure it's in the clamp, and then you can check to line it up with the saw and then lock it in place in the clamp. So the metal chop saw has a sort of sliding clamp on it, or vise, and you can use that. And the woodworking chop saw has a clamp that comes from the side and wraps around and locks down onto your piece of material. So you want to make sure there are any cords or fingers or anything out of the cutting path of the blade besides what you want to be cutting. So make sure that, again, the cord of the saw isn't draped over the cutting area. I know that sounds silly, but it happens. You want to make sure, again, your hands are out of that cutting space. So normally chop saws, I know the wood one below, the DeWalt, I think there's some other brands that have it too. They actually have spots where they'll show you on the saw to place your hands. And the best idea is place it as far away from the cutting area as you possibly can. But yeah, you want to start the saw at the top of its arc. So they lock in that position at the top. And normally there are buttons on the handle that are there's a safety, and then there's a start button on that saw. And you want to start it at the top when the guard is fully engaged. So if you see in that picture there on the bottom right, the guard covering the saw is fully engaged, and that's when you want to start it. You never want to start the saw with the blade exposed. So you start the saw on the top of that arc, and you pull it down into your work, and you cut slowly, applying pressure as you move through. So you'll feel it catching the material, and you'll cut right through. Blade's spinning fast, so it should cut through easily. The metal one is a little bit different. It feels totally different, and depending on what you're cutting, it'll slide through. So you want to, once you make that full cut and you come to the bottom of the arc, when you're done cutting, you want to release the safety and the power button. The saw is slowly going to spin down and stop spinning. And then once it stops spinning, you're going to release it, pull it back up to the top of the arc, and then remove any material. You never want to reach in when the saw is still spinning, even if it's cut off, it can still cut you. And the last thing we're going to worry about is the lathe. So most, if not all, injuries from the lathe come from entanglement. That means that there's hair hanging down, there's something like baggy clothes getting in the way, someone's hand gets in the machine. The lathe is spinning at a very fast speed. It's spinning very accurately, so you need to keep loose items away from the machine and tied up, even if you were nearby. Even if you're not the operator of the machine, if you're near the lathe, make sure that nothing is hanging down from what you're working on near the lathe. The lathe is a really special piece of equipment. It's very unique, and it's going to be used by designated students. So obviously, if you want to use the lathe, if you want to learn how to use it, someone can teach you how to use that. But it's not really a machine that we want everybody standing in front of and working on. It takes practice, and it's very specific how you need to use it. So we ask again that if you want to use that machine, that you ask somebody or you're someone that's trained on it. You want to keep the working area of the lathe free of scraps and tools. Tools can get in the way when it's spinning and get launched out of it. You really want to keep that machine clean, and the students that use it take good care of it and try and keep it that way. Make sure the machine is off before you mount or remove any accessories or material. So again, it's spinning very fast. You don't want to be attaching anything while it's spinning. That's a horrible idea. You don't want to be inserting any material while it's spinning. That's a horrible idea. And we also have a CNC machine in the shop, and that's sort of like the lathe as a specialized piece of equipment. And that's something that you can get trained on, but it's not really something that any student can just walk up to and use any time of the day once they've been trained on it, like the bandsaw. Like the bandsaw, if you're trained on it and students have to go cut something on that. But the lathe and the CNC are different. All right, does anyone have any questions they want to type in the chat that I can answer?
Thank you all for coming to the presentation. I hope you guys have a nice evening or night wherever you are, and have a good one.